So our lesson today was on drawing polyatomic ion structures using the Lewis dot diagrams. And we have our process of several steps to do that. Let's get started. I would like to do phosphate, PO4 minus 3. So step one, count your valence electrons. Well, we have one phosphorus. There are 4 oxygens. And we have a minus 3 charge. So let's add all that up. Well, each phosphorus has 5 electrons in its dot diagram. Oxygen, of course, has 6 because it's a group 16 element, so 4 times 6. Plus an extra 3 because we have a minus 3 charge on this. So that is 32 valence electrons that we have. So remember, what we're doing is we're counting the dots. Again, phosphorus is a group 15 element, so 5 dots. 16 element for oxygen, so 6 dots. So we have 32 electrons total. So that's step one. Step two, draw the skeleton structure. Well, we know the central atom must be phosphorus, and this is the one written once. So I'm going to go phosphorus, and I'm just going to put 2 dots between each oxygen. And that is our skeleton structure. Showing phosphorus in the middle, surrounded by 4 oxygens on the outside. Okay, all right, step 3, complete the octet for the outer atom. So we have at this point a phosphorus with 2 dots for each oxygen. We'll put that back up there for you. All right, now complete the octet for the outer atom. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We're completing up every one of these. 1, 2, 3, 4, 5, 6. So now we have 8 on each of the oxygen, 8 around the phosphorus, so that all looks good. So we got 4 times 8, that is 32 electrons total. So we're done with this structure. So it says give the remainder electrons to the central atom. Well, there are no valence electrons left over. And do multiple bonds to complete the octet of the central atom. So we already have a central atom that has an octet. So we're done. This is the structure, okay, for phosphorus to oxygen. Now we notice that there's 4 bonds and no lone pairs. So this one is tetrahedral in shape. So there you go. What's the next one we want to do? Next one is sulfur dioxide. All right, so count our valence electrons. Well, we have 1 sulfur, 2 oxygens, and we don't have a charge this time, so no extra electrons there. So sulfur is a group 16 element, so it's 6 dots. Oxygen is a 16 element, so 6 dots, but there are 2 of them. We need to add this together to get 18 valence electrons. Next step, draw the skeleton structure. So sulfur, 2 dots with oxygen, 2 dots with oxygen like this. There you go. That is our skeleton structure. Next, complete the octet for the outer atom. So let's draw that skeleton again. 1, 2, 3, 4. We have our oxygens like this. So now we're going to complete the outer electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we go. Now let's see how many electrons we've used up. We have 8 times 8 is 16, but we have 18 total to do. We're going to put the extra 2 dots then on the central atom. So we have only used up 16. We have 18, so the central atom will get the extra electrons. Step 5, do multiple bonds to complete the octet of the central atom. Well, let's take a look. We know there's 8 dots on each of the oxygens, but there's 2, 4, oh, there's only 6 electrons on the central atom. So we need to do a double bond. Now you can double bond either side. You can double bond the right side or the left side. So how are we going to do that? Well, we're going to put 2 more electrons from oxygen also into the middle here. So what is that going to look like? So we'll draw sulfur like this. We're going to put 2 electrons there for it. Okay, and I'm going to do the electrons for oxygen like this. 1, 2, 3, 4, 5, 6, and then we'll do all the other oxygen here like this. So what have we done? We've made a double bond. We have shared 4 electrons between the sulfur and the oxygen, or 2 electron pairs. That is a double bond. Now when we count, we've got 1, 2, 3, 4, 5, 6, 7, 8 electrons around the sulfur. There's 8 electrons around this oxygen and 8 electrons around this oxygen. So do multiple bonds on the central atom when you need to in order to complete its outer octet. Okay. So what shape would this be? Well, this looks awful familiar. It looks like a bend-shaped molecule. Okay, and that's how you draw dot diagrams for polyatomic ions.